Good evening, everyone. My name is Nihar Modi. I lead product management for Amazon Managed Blockchain. Today, we're going to learn a little bit about blockchain and also dive deep into the service. And thanks for being here. I know it's 4:45. This is going to be fun. All right. So let's start with the million-dollar question, right? Like, what is blockchain? Before we get into that, I want to give you a little bit more information on what inspired us, right? I think this is roughly around 2017, 2018. We started seeing a bunch of articles in the news around blockchain as to how it was going to be the backbone of supply chain 2.0, right? We started seeing a bunch of articles around how blockchain was going to change the finance industry. We also saw a bunch of articles around how blockchain was going to transform the healthcare industry as we know it. So we looked at all this information and we were like, hey, we should actually talk to our customers to see how they plan to incorporate blockchain into their businesses. So we went and talked to a bunch of customers after this, and we essentially found out that customers were looking for two different things, right? There's a first set of customers that wanted something which we call the ledger, right? They basically wanted a system of record, and they also wanted that system of record to be immutable, right? And for these set of customers, it was extremely important for that data to be owned by a central authority, right? If you look at some of the classic use cases, DMV comes to mind. We talked to a few of those DMV companies, and essentially DMV has all the information about vehicles that are in the state. They also have a history of those vehicles, right? But if you look at a DMV use case, all that data stays within the DMV, right? For these set of customers, we ended up building Amazon QLDB. QLDB is Quantum Ledger Database, and Quantum Ledger Database basically has two main components, right? If you look at the bottom there, it basically has a journal component, which is an append-only journal, right? And it essentially has an immutable log of all the transactions. The second component is the database, and this database essentially has the current state and the indus history of all the transactions, right? So these two components together essentially form QLDB. So if you kind of follow the arrows over there, from your application, when the data comes in, it first gets written to the journal. From there, it gets written to the database, and then you can obviously query this data as and when you need it. For the second set of customers, we essentially talked to a bunch of these customers, and they told us that they wanted to run transactions in a more decentralized way. And this is a use case that really excited us, right? We talked to a bunch of financial institutions. They were interested in doing a bunch of peer-to-peer payments and peer-to-peer transaction applications, and they said it's extremely important for them to actually independently verify these transactions. Right? We talked to a bunch of supply chain customers, and these supply chain customers said it's extremely important for them to actually look at the same data at the same time, right? Supply chains are getting more and more complicated. There are a lot of different organizations that are involved, but they all don't look at the same data, right? The third set of customers, we talked to a bunch of mortgage lenders, and mortgage lenders essentially didn't want to deal with any central authority, right? So we started looking at a bunch of these use cases and found out that, this is super interesting for us to actually probe further. So what does a multi-party business actually need, right? It actually needs a way to independently verify transactions. It also needs a way for everyone to look at the same data at the same time. Like, that is crucial, right? And the last thing we heard from customers was that they all wanted to make sure that the data was tamper-proof, right? It's super important. So these were some of the requirements that we gathered from our customers. A lot of customers told us that today they were doing that using some really primitive approaches, right? Like, a lot of these customers were actually using some sort of central authority to securely share this data, right? A lot of customers were using expensive escrow services that they didn't want to deal with, right? So these were some of the current approaches that we found out from our customers. So in comes blockchain, right? What does blockchain really do? So we kind of asked ourselves this question, and the real answer is blockchain helps build trust in the network, right? It helps build trust such that these different organizations can come together, they can transact without any central authority, right? How does it do it? There are three main components to blockchain. There's a distributed ledger. There's the consensus mechanism, which is essentially how a network says yes or no to all the transactions, right? And then there's the smart contract layer. Together, these three components help build trust so that everyone can transact without a central authority. So let's dive into each one of these three components, right? Like, what is a distributed ledger database? So if you look at the distributed ledger database, this is similar to the QLDB slide that we saw earlier, right? There are two components. It's got a journal component which records all the immutable log of all the transactions, right? And it also has a database component, which is the current state and the index history of all that data, right? And if you look from a blockchain perspective, you guys have heard of nodes, and all the nodes essentially have a copy of this distributed ledger. Second component, so this is the consensus mechanism, right? Essentially, this is the way a network actually agrees on transactions and blocks, right? You hear about a lot of these different frameworks, and one thing that changes between these frameworks is how these frameworks actually reach consensus, right? So you've heard the Bitcoin network, this proof of work where everyone solves a complex puzzle, right? So that's the proof of work consensus mechanism. There's also proof of stake. There's also proof of authority. So there are a bunch of these consensus mechanisms that are out there for all these different blockchain frameworks. One thing to note is the consensus mechanism is really what impacts the transaction rate, right? It also impacts the energy requirements that your blockchain framework is going to need. It also decides what hardware you're going to require for your use case, right? And security is another thing that is important, and the consensus mechanism is really the key to that. The third thing that is important in blockchain component is a smart contract. So this is a word that I hear a lot when I go talk to customers. Like, I keep hearing everyone wants to build a smart contract. And essentially, smart contract is nothing but a business logic code that resides on a blockchain, right? It is also the same code that writes to the ledger. And you can think of a smart contract as a liaison between your blockchain network and your outside world, right? It's also called off-chain in a lot of different blockchain frameworks that you'll see. It's kind of summarizing all of this, right? There are three components to blockchain. At the bottom of the stack, you essentially have a distributed ledger. In the middle, you have the consensus mechanism. At the top, you essentially have a smart contract, and together, these three components help build trust in a network. So what are the current challenges with existing blockchain solutions, right? The number one thing that I hear a lot is that the setup is extremely hard. Most customers don't even get past this first stage, right? And this is because, by the very nature, blockchain is not easy technology. And when you start diving into a bunch of these different frameworks, they're pretty hard to set up, right? It's also hard to scale. Like, we come across a bunch of customers that say that, hey, we have a blockchain network. Right now, we're the member. When we start adding new members to this network, like, everything just falls apart, right? So scaling is a big problem. It's also complicated to manage, right? So think about it from a billing aspect. Think of it from, like, a governance model. Think of, like, security aspects of things. Like, this is extremely difficult. Like, it's not easy to actually manage a blockchain network. And the last thing we hear from customers is that when they try to do it themselves, it's very expensive, right? It's not an easy thing. So we'll get into the Amazon Managed Blockchain Service, right? So what is Amazon Managed Blockchain? Right? Amazon Managed Blockchain essentially is a fully managed service that makes it easy to create and manage blockchain networks. Today we support HyperLedger Fabric, and Ethereum's coming soon. Right? here are some of the features that Amazon Managed Blockchain provides. Right? The first one is that it's actually a fully managed service. You can create a blockchain network from the console or the CLI in literally minutes using Amazon Managed Blockchain, right? So it's the first step that we talked about where most customers falter. You can pass that in like minutes. The second feature is we support open source variety frameworks. Like I said, we support HyperLedger Fabric today. Ethereum's coming soon. And we'll dive deep into these frameworks a little later. It's also decentralized, right? Like we built a bunch of features that enable you to democratically govern the network, right? When you have members, you want to have that sort of governance model. It's also reliable and scalable. So we've actually used the same technology that powers QLDB in Amazon Managed Blockchain, and that essentially has helped us make the system more reliable and durable. It's also low cost, right? So a pricing model is essentially pay as you go, right? If you're using those resources, you pay for it. If you're not using those resources, you don't pay for it, right? And the last thing is integrated, right? And I want to spend some time here because it's one thing to actually have open source frameworks, and it's a completely different thing to actually take these frameworks and put them in production, right? So there's a lot of integration work that we've done in Amazon Managed Blockchain. For instance, under the hood, we actually use AWS KMS technologies. We've integrated with CloudWatch metrics. We are in the process of integrating with CloudWatch logs. We've integrated with CloudFormation. And these are some of the things that customers have asked for, right? Like they want us to do things that enable them to go to production, and like they wanted us to integrate with a bunch of different AWS services. How does it all work, right? So it's pretty simple. I call it the four-step process. The first step is you actually create a network, right? And this is super easy to do. You can actually do this via the console, the AWS SDK, or the CLI. You can also choose what framework you want, and within minutes, you're going to have your blockchain network that's up and ready. Once you do that, the next step is to start inviting members. And this is another piece of feedback that we got from customers that it's not an easy thing to do. With Amazon Managed Blockchain, you essentially call an API or do it from the console and start inviting different AWS accounts to join and become part of that network. Once you do that, the next obvious question is like, okay, this is great. How do I actually submit transactions, right? This is when you would start provisioning your peer nodes. And peer nodes is a component which essentially stores the distributed ledger. It also has the smart contracts that you can then invoke from outside to write to that ledger, right? And we've got a range of different instances that you can provision using Amazon Managed Blockchain depending on the throughput that you're going to pass to the system, right? And then once you've done all of that, the last step is to start deploying your applications, right? In terms of deploying applications, you would start deploying your smart contracts and also your client-side code that will help you interact with the blockchain network. So most of the customers that we talk to, they want to get to step number 4, right? But they could not even go through the first step, and hence they're like, hey, how do I actually start submitting transactions? Like, this is what we want to see. And with Amazon Managed Blockchain, you can essentially get to that step in minutes. So let's talk a little bit about these two frameworks that we just discussed, right? So we've got HyperLedger Fabric and Ethereum. HyperLedger Fabric is essentially a permission network. Ethereum is a public network, right? Why would you need these things, right? So if you look at Fabric, it's used in applications that have stringent privacy requirements, and you also have tight permission controls, right? If your application requires that, then more likely you're going to use Fabric over Ethereum. If your application actually requires transparency of data between the different members, then you're going to use Ethereum. So if you kind of take a couple of use cases, think about a consortium of banks, right? Let's say there are 5 banks, and 2 of them actually want to trade between themselves, and that data needs to just reside with the 2 banks that want to trade between themselves. You can do that in Fabric, such that the other 3 banks don't have access to that same data, right? Ethereum, on the other side, think about a use case where a country decides to share data that is helpful for farmers. For example, crop yields, weather information, land information and a bunch of other things, and they want all the farmers in that country to have access to that data, they would essentially put that on a blockchain network that is on Ethereum, right? So there's two different frameworks. It really depends on the application that you're trying to build at the end of the day as to which one you would go pick. So one of the questions that we get asked a lot is who owns the network, right? And my answer to that is everyone owns the network, right? It's truly a distributed model. So if you really think about it, networks are decentralized, and the way Amazon Managed Blockchain works is you could create that network, and for whatever reason you decide to leave it because it's not helpful for your business anymore, that network still stays on until the last member leaves, right? Because these guys are still transacting on that network. The second thing that we've done is we've built a bunch of features around, like members can actually vote to invite others and also remove others from the network, right? So it's really a democratic system that we've built on top of what open source actually offers, right? And it's really every member pays for the resources that they use, right? And this is important because when you start doing it yourself, like we've run into customers that have told us that, okay, now we have 3 members, like how do we split costs, like how does billing work? We've actually done a bunch of work to make that super easy. The bill that you see is basically for the resources that you've used. So let's talk a little bit about how we've augmented Fabric, right? There's a component in Fabric, it's called the ordering service. You can think of it as the heart of the system. It's a system that essentially creates and cuts the blocks. And if you look at the open source production grade networks, these networks are using Apache Kafka for this component. We've replaced that with the same technology that powers QLDB. And the reason we did that is because we're seeing increasing durability and a lot of better reliability when we actually did that, right? The second thing is the certificate authority, and this is essentially the thing that maintains the identity of a member in a network. And with certificate authority, open source will say you've got to use some sort of a soft HSM technology. HSM, as we all know, is tough to manage, it's expensive. We've actually used the technology that powers AWS KMS service in Managed Blockchain for the certificate authority service. So let's look at some of the pricing dimensions, right? Like I said, it's really a pay-as-you-go model, right? And there are no upfront costs for this. There are 4 different pricing dimensions, right? The first one is, it's like, think of it as being part of a tennis club, right? And you're paying a monthly fee as long as you're part of that tennis club. We call that the network member fee, and it's on a per-hour basis. The second dimension is the data that you write into the network, right? And that's, again, it's just the data that you write, not the data that you would extract out of the network. The third one is the nodes, right? Nodes are the ones that actually store your ledger. They enable you to submit transactions. And nodes are the ones that you get all these options for, and you're basically billed on a per-hour basis. And also the node storage, right? So nodes are where, like I said, the ledger resides. And as your ledger grows, like your storage would grow, and that's what we bill you for. So these 4 components, pretty straightforward. So we'll take questions after. There are 2 different types of memberships. There is a starter membership and a standard membership. I want to highlight that in terms of production grade, they're both production grade, right? The only difference is that in a starter network, you can expect to see lower throughput than what you would see from a standard network. That's the only difference, right? And what we've seen customers do, a lot of customers that are running some tests or some small production networks, they're using the starter membership. And customers that are actually building applications for production, they're going to the standard edition because they are expecting throughput out of the system. All right, now let's dive deep into HyperLedger Fabric on Amazon Managed Blockchain. It's a complicated diagram, right? But we'll make it easy. So 3 main components over here, right? So the gray boxes that you see, there's the Fabric ordering service. Like I said, this is the heart of the system. This is the system that actually cuts the block. There's a Fabric CA, which is the Fabric Certificate Authority. and the certificate authority is what maintains the identity of a member in a network, and peer nodes are essentially your nodes which store your ledger and also enables you to transact with the network, right? So now, let's say I'm member A, and I'm looking to actually create a network, right? When I go on the console, I create a network. As part of the managed service, we essentially provision the entire ordering service for you in minutes, right? Member A, when they create the network, they also get the Fabric CA node and that entire service as part of the managed service. Like, you don't actually have to do anything, right? Once member A has now created the network and they want to invite member B and member C to this network, they essentially use the invitation APIs, and they would invite member B and C, and once member B and C actually accept the proposal, they become part of the network one. It's literally as simple as that. One thing that we've done is all communications into the blockchain network is all going via AWS private link, right? So let's say you've got an application in account A, and it's sitting in its own VPC, you would actually use AWS private link to connect and talk to your blockchain network. So it's, from a security perspective, a lot of customers actually like that. So let's look at the transaction flow, right? So there are three different entities here. You've got the submitting client, which is your application side. You also got a bunch of different peer nodes in the middle, and then you've got the ordering service there on the right. The step number one is for the client to actually submit a transaction proposal to the peers. The peers will then simulate these transactions, and they'll send back the endorsement signatures to the client. So the peers are either going to say that I'm okay with this transaction or I'm not okay with the transactions. The client essentially just assembles all these signatures, and then it takes all these signatures and broadcasts all the endorsements to the ordering service, right? The ordering service will do some sort of verification, and once that verification is done, it'll essentially send the block to the peer, and the peer will take that information and put it in a ledger. It sounds complicated, it's really not. Like, you do the first transaction, and then it's pretty straightforward as to how this thing works. Now let's look at channels and access controls and private data collection. This is super important, right? A lot of people actually use HyperLedger Fabric for a couple of these features here. What channels essentially does, it enables you to isolate transaction. So think of this use case here. You've got member one, you've got member two, and you've got member three, right? Like, think of this as a banking consortium with three different banks. And if bank number one and bank number two want to run some transactions such that bank number three doesn't have access to that transactions, they can do that via channels. When you create a channel, essentially what Managed Blockchain does, and this is also part of HyperLedger Fabric, we actually create a standalone ledger for that channel, and that ledger is such that member three or bank number three has no access to it. And a lot of our customers today like this feature, and that's why they're also picking HyperLedger Fabric. The next thing is private data collections, right? And private data collections within HyperLedger Fabric essentially allows you to store PII data if you want on the ledger. And it's, again, super powerful feature for some use cases that actually require PII data to be on that ledger. All right, now let's look at endorsement policies. Endorsement policies essentially allow chain code to specify which members need to validate a transaction before submitting, right? So as part of the endorsement policies, you can say, hey, I'm in a network, there are, let's say, 10 members, but member A, B, and C, these are the three members that need to validate my transaction. You would define that in your endorsement policy, right? And it's pretty straightforward, and most codes that we've seen is literally a line of code with a bunch of operators, right? Once that endorsement goes through, the client essentially gets that endorsement from the peer nodes. It makes a package of that endorsement and sends it back to the ordering service, and then the ordering service kicks in and starts cutting these transactions into blocks and then sends it back to the peer to store in a ledger. Chain code basics. So let's learn a little bit more about chain code. Like I said before, chain code is essentially the code that is executed on the blockchain network itself. It's also the way you would actually query and write to the ledger, right? Fabric supports 3 different languages in how you can write this chain code. You can either use Go, Node, Java, right? And what we've done as part of the managed service, you could have multiple chain codes on a peer node. And in Amazon Managed Blockchain, essentially all these chain codes are running in their own containers. Like, again, you don't have to manage any of those containers or any of that. Like, that just, like, we take care of that as being part of the fully managed service. Chain code sounds a little complicated, but it literally just has 2 methods. The first one is the init method, where you try to initialize the chain code on the network. So this is how you would say that, hey, this is my chain code. I'm good with it. Now I want to put it on the network. And you call the init method for that. The second one is the invoke. Like, once you've got the chain code on the network, you would essentially submit transactions, and you do that by calling the invoke method, right? And literally, there are just 2 different methods that are available for you to interact with your network. Peer nodes. Peer nodes are a very crucial piece of any blockchain network, right? And they literally do 3 things. They actually execute chain code and endorse transactions. They also store a copy of the ledger, right? Like, a lot of customers ask us that, hey, how do we access the ledger? It's basically via peer nodes. The last thing it also does, it actually validates transactions before committing to the ledger, right? It ensures that all the policies are being met, all the right transactions are basically being appended to the ledger, and that's the ledger that is available for customers to query or do like off-chain analytics or things like that. All right. Cool. Now I'm going to introduce Shruti Rao. She's the head of BD for Amazon Managed Blockchain, and we're going to walk through a bunch of cool customer stories.
All right. Nihar.
Thank you.
All right, you guys. The first part we looked at, what is blockchain and what is Amazon Managed Blockchain? Why did we create 2 services? How did we create 2 services? What was the genesis of that? And how blockchain on Amazon Managed Blockchain itself works. Now, the question that we get asked is, what is it being used for? Is this a solution looking for a problem? Is it still an experimental technology? Is this something that is production ready, or is our customers using this in production? So this is a section where we talk about customer stories and dive deep into what our customers are usually using it for. And we also have Casey from Workday who will talk about Workday's use case for Amazon Managed Blockchain. But first, let's step back and take a look at what is our customer using this for? The first question that gets asked is this some kind of a Bitcoin-like implementation? Well, it's not. We see that there are 3 big use cases that our customers are using for. The first use case is for supply chain, for track and trace, whether you're tracking and tracing data or you're tracking and tracing stuff, whether it's produce or diamonds or oil and gas or water at some point. So that's the first use case. Now, our customers also ask us, why do we need to track and trace this stuff? Why is this important? Now, everything is transparent, so now what? By tracking and tracing any of their goods and services, our customers are now able to take the next step decisioning process. If I know where my spinach is, and if the spinach went from first quality to second quality, now I know what steps I can take with it. Maybe I can make it frozen spinach or use it in some kind of a smoothie processing plant. Now I can also find out where the leakage is. We have a customer that is the purveyor of cell phone. They assemble cell phone parts. Now this customer is able to understand where the purchase orders are being missed and which particular distribution center or the trucking company is losing these boxes, so they can correctly monetize each of these players in the value chain so that this leakage doesn't happen, rather than just peanut buttering the cost across everybody in their value chain. So that's pricing on payments and next step decision making for supply chain is our first bucket. So our second bucket is trade finance. Trade finance is exchange of goods and data. Anytime there's a supply chain transaction, some kind of a payment needs to be made on it. But for a large purchase, let's think of lumber or coal, which we will talk about in a few minutes, or steel. You're sending hundreds, if not thousands of metric tons of product, and the seller needs some kind of a supply or buyer guarantee or creditworthiness of the buyer when they're sending this overseas. So letter of credit is one such process that's used. So that's our second use case for trade finance. Our third use case is settlement and clearing. Usually settlement and clearing, think of stock exchanges, also think of insurance settlements or retail settlements. So when there is a settlement and clearing transaction, in the old world, before the blockchain came into existence, there were multiple parties and information was sent from one party to the next without having a really prescriptive way to understand if the data changed accurately, if the data is being tracked accurately, or is the person or the entity that is supposed to change the data changing it, or is it falling into malicious hands? It could also be just human error, which was more often than not than malicious acts. So that's the third use case of settlements. So we'll talk about all that. Each of these have an example, and we'll dive deep into each of these use cases one by one. So first use case that we see is Nestle tracking their first product, which is single origin coffee on Amazon managed blockchain. Coffee, this is what I learned after started working with Nestle, is the second most traded and exported commodity in the world after oil. And Nestle is one of the biggest purveyors of coffee in the world. What Nestle really wants to do is Nestle realized the coffee growers, the farmers, were the least equitable party in the whole of the coffee supply chain. So they wanted to take their first product, which is a premium single origin coffee, from one farm, one section of a farm, and map every single handshake that the coffee goes through. So if you go to Aria, the resort Aria, you go to Quad, and we have a Nescafe zone there, and you will find this coffee. You can also go on chainoforigin.com and find this coffee, and it's a subscription coffee. And this coffee has a QR code here. And when you scan this QR code, with Amazon Managed Blockchain, now Nestle is able to give you information from who that farmer that grew your coffee, what part of the farm it was harvested in, who roasted it, which truck it got transported it, where was it bagged, which ship it sat on, and how it got you. If you buy the subscription, you will also see your name on it as the person drinking the coffee, unless someone else in your house drinks it. So you have the entire lineage of coffee in this one bag. So that's the power of traceability. Now, this obviously is to show that they can track the single origin-ness of a coffee. Now you ask, why did Nestle have to track this? Now, this is a premium coffee, and it comes with a nice price tag. So if the single origin somehow gets mixed up and becomes, let's say, a double or a triple origin, which is not a single origin, it may not hold the same price tag or the brand value as a single origin coffee does. So Nestle is committed to identifying where the leakage is, plugging those leakages, and then giving the money back to the farmer who produced it. So they are equitable in this particular supply chain. So that's one of the use cases for our supply chain use case. Second one, this is also a supply chain use case. We don't think of that because this is tracking music rights. This is, again, a track and trace. Sony has created this platform where they are tracking music rights for music composers. If you step back, in a current day scenario, if you are a music composer or an artist, you spend more time figuring out how do you create IP for your content, trademark it, make sure that somebody doesn't plagiarize it, and protect your creation. What Sony Music of Japan is, Sony Music Entertainment of Japan is doing is on its platform, as a music producer, you can put your music and then register it in your name and in your credentials, and they track it at every step of the way, from the music was created by such and such a person, it was bought by such and such a person, or the rights were bought by this and this company. So the next stage of this evolution is it makes it very easy for music composers to just do what they're really good at, produce music, and monetize it on the platform, rather than go through multiple parties and multiple steps, and see how their music sales are doing on the platform. Again, one is Nestle's use case is tracking goods, which is a coffee, and then Sony is more of tracking data, both of which is supply chain use case for pricing and next step decisioning processes. The second bucket that we talked about, or the third bucket that we talked about, was the settlements case, and Singapore Exchange is an example of that. So Singapore Exchange is an exchange that works on all classes of assets in Singapore, and they're working with the Monetary Authority of Singapore and 17 other banks on a project called Project Ubin. Project Ubin is committed to bringing liquidity to the Singaporean market. And how do they do this? They've come up with a mechanism called delivery versus payments, DVP. What it does is, in the old world, when, let's say, I stole a stock of share on Singapore Exchange, I was involved, my bank was involved, Singapore Exchange was involved, the buyer and the buyer's bank was involved. And the data went back and forth, and this took multiple days to settle this transaction, this one transaction. And what Singapore Exchange, or for a matter of fact, any exchange in the world does, is they take their treasury bonds or treasury money that they have liquidity in their treasury and front that till this transaction settles, and then they recover the cost. In case of some kind of a upswing in the stock market or a downturn in the stock market, there is no liquidity because the exchanges, in this case, Singapore Exchange, has fronted their treasury funds. So Singapore Exchange was able to use Amazon Managed Blockchain to track one form of security, that's the Singaporean bonds, to see how fast they can settle this transaction. What they found is that now they can settle any type of a transaction, whether it's bonds or Singaporean dollar or exchange-traded funds, quite in near real time, not many, many days, within a few hours after that transaction happens. Now, they also realized that because using blockchain and using some kind of an asynchronous event-driven architecture, they can do ad hoc, on-demand settlement. So if you want a transaction to be settled 3 days from now, you could. You don't have to do it now. So that's the combination of event-driven architecture along with Amazon Managed Blockchain. What did this do? Again, this is for one single asset class that they have tried, and then they have plans to expand on other asset class, is they immediately found that there was a higher liquidity in the market because they were not fronting as much funds upfront. So that was one of the really good benefits that they've got. So once Singapore Exchange has converted and moved over all of their asset classes onto a blockchain-based settlement and clearing system, they expect that the liquidity to be brought to the market within a few hours, as opposed to a couple of weeks now. Legal in General is another settlement engine. Legal in General is another settlement example. Legal in General is an insurance provider in UK. They're also one of the largest reinsurance providers in UK. So what do? They do two things. One is they look after pension funds within UK. These pension funds are usually 40 to 50 years long. Customers like ourselves pay into pension plans every 2 weeks with our paychecks. And Legal in General contracts this out or farms this out to many of their pension funds. As you know, there are many different types of pension funds. And the reinsurance system, on the other hand, that's their other business, is actually covers these pension funds. So pension funds take the consumer's money, and then they invest in it in long-term funds, whether it's venture capital, investment banking, what have you. So it produces returns for the pensioners, for the investors, in this case, consumers. When, let's say, I retire and my pension is called, that money, my funds, needs to be there to pay me out. In case the investment is stuck somewhere or is still in a 3-year type of a situation, then Legal in General covers my risk and brings liquidity back to the individual pensioner. So they've used Managed Blockchain on top of their S2RA platform, which covers over 100 different type of pension funds and pension plans in UK. And this particular platform is an n-sided marketplace, which balances out the risk between each of these pension funds. So at any given point in time, if one pension fund is called and it's running low on funds, the risk is transferred and managed between 100 and X number of other pension funds, so this pension fund gets paid. So that's one of the other settlement use cases. So the last bucket that we talked about, this is the second bucket we talked about, treasury finance bucket, is letter of credits process with Contura Energy. Contura Energy is the biggest coal extractor and exporter in the United States. They ship around 8 to 10 million metric tons of metallurgical coal each year. Metallurgical coal is used to make stainless steel. It's used to make coke, which then used to burn and make stainless steel. All of the axles in our cars that we use in the United States has somehow connected to Contura Energy's coal, which is great. They ship to over 60 countries worldwide, Turkey, Brazil, Ukraine, India. And there are these buyers, and they have these relationships with buyers of these coking coal or metallurgical coal. What they don't have is, they are stuck with a process that was last invented in 1933, which was paper-based process called letter of credits. So what is letter of credits is, the buyer, let's say in Brazil, has, every week, Contura sends about $5 to $7 million worth of coal to a particular customer in Brazil. $5 to $7 million a week, about 40 to 50 times a year. So they need some kind of a guarantee that they will recover this money. So the buyer's bank in Brazil uses their creditworthiness as a backup for the buyer's creditworthiness. And then when the purchase order is created between Contura and their buyer, a SWIFT account is made, a SWIFT transaction is made. So now this process of Contura being able to recover their money takes 6 months. Now with Amazon Managed Blockchain-based letter of credit solution, we haven't changed the business process. The business process remains the same, it's compliant with regulations, but the 6-month-long process will be reduced to under 21 days. So now Contura can recover their working capital, which is $5 to $7 million a week, 40 times a year, for one particular customer from 680 days to 21 days. That is the power of using some kind of a blockchain technology along with other solutions. Fun fact is when a SWIFT transaction comes in, when the buyer says, I need 5 metric tons of coal, they send a SWIFT code, SWIFT transaction. And if my name or my address is spelled wrong, let's say Boulevard becomes BLVD, or my name has another I at the end with Shruti with 2 I's, that typo needs to be replicated in every single document or that purchase order, and that transaction becomes, is declined by the banks. That is not because of banks, that is because of the UCC code that was set up in 1933. With Amazon Managed Blockchain and Amazon Textract, we are able to reduce this back and forth to correct a spelling mistake and make this process very efficient. So some of the use cases we're talking about, I also will tell you about another exciting use case that we have, and we will tell you where to go. Kabru is one of our customers. Kabru is a distillery in Korea, the oldest distillery in Korea, and they brew IPAs. These are just 2 of them. There are more. So these 2 beers have been on Amazon Managed Blockchain. So we have coffee and then beer. And both of these are available in Aria, in Quad. So I talked to the CEO, and he said the IPA was the crowd favorite in Korea, and I happen to agree with him. So go to Aria Quad, and we have the details for you, and get your own as well as coffee. So these are some of the use cases. We'll get Casey Lucy from Workday to talk about their use case, and then we'll wrap it up, and we will have time for questions at the end. Thank you.
Hey everyone, my name is Casey Lucy, and I'm an engineer at Workday. Workday is a leading provider of enterprise cloud applications, including financial management, human capital management, planning, analytics, and analytics, all designed for the world's largest organizations. I helped design and build the blockchain infrastructure for a new product called Workday Credentials. So what are credentials? Credentials are a way of proving our identity or qualifications. If you traveled here by plane, you had to show a form of photo ID, which is a credential issued to you by the government that proves your identity. When you go to rent an apartment, you often have to provide proof of income or employment. This is often done by emailing or printing pay stubs to the rental agent, who then has to verify the contents of those documents. Workday Credentials is providing a secure way to share and verify this information instead of requiring physical documentation and human verification. In the center of the screen, you can see an example of the Workday Credentials UI. Customers can use the Credentials UI or the underlying APIs to configure, issue, and verify digital credentials. Let's say, for example, Sarah is an employee at Global Modern Services, and she recently won the Employee of the Month award. The Employee of the Month at Global Modern Services gets as much free ice cream as they want. In order to prove that they're the Employee of the Month, Global Modern Services issues a credential to Sarah, and then Sarah can present that credential to receive free ice cream. On the right side of the screen is the Way2 mobile application, which is the consumer-facing app where users can control their credentials and share them if they want to. This is Sarah's first credential, so she'll first receive an email to onboard to the platform, and then store and share her credential from her smartphone. I'll dive into Sarah's onboarding process in a few slides. So how does this tie into the blockchain? We use the blockchain as a trusted source of truth for public keys and other information necessary for sharing credentials. Blockchain provides us with a solution for interoperability with partners through a consortium. Members of the consortium can independently read and write information from the blockchain. All of our credentialing services and APIs are built on top of Amazon Web Services using things like API Gateway, Lambda, DynamoDB, and Managed Blockchain, among others. Throughout the user onboarding, credential issuance, and verification process, we use Amazon Managed Blockchain to store public keys, the shape of credentials, and a registry of revoked credentials. Amazon Managed Blockchain helps abstract the complexity of running, growing, and operating a blockchain network, allowing us to focus on what we do best, building applications. So how do we use all of those services throughout the platform? Touching a few key points of this diagram, we have a blockchain adapter service, which runs as a set of lambdas that's responsible for abstracting the ledger from the rest of the platform. We have a set of lambdas that we use for blockchain administration, things like installing chain code, upgrading chain code, and modifying the channel configuration. We have a ledger client, which is responsible for invoking the chain code to read and write information from the blockchain. And we use DynamoDB throughout the platform to store metadata and as a temporary data store for objects destined for the ledger. So let's go back to the process of Sarah onboarding to the platform. When she signs up, a key pair is generated in the Way2 mobile application, and the private key is stored in the secure enclave of her device. The key never leaves. The public key is sent to our platform in the form of a DID document, essentially a format for storing public keys on the ledger. The platform sends the DID document to the blockchain adapter service, which writes it into DynamoDB. The DynamoDB write operation triggers a DDB stream, which in turn triggers a Lambda. That Lambda takes the record and writes it into an SQS queue. That queue feeds into our Ledger client service, which is responsible for using the HyperLedger Fabric SDK to invoke the chain code, collect the endorsements, send the transaction to the ordering service, and wait for the transaction to be committed. Once the transaction has been committed, Sarah's public key can be used to issue and verify her credentials. In this case, Global Modern Services is issuing the credential to Sarah, and so they also have a key pair, and their public key is stored on the ledger. When the credential is sent to Sarah, Global Modern Services signs the credential with their private key, and the credential is stored on Sarah's mobile app. So when Sarah wants to go present her credential to get free ice cream, she sends a request to a verifier, and that request is signed using her private key. The verifier must read Sarah's public key and the issuer's public key from the ledger, and using those keys from a shared source, they can verify that the credential was issued from and shared by the correct entities. The process of reading from the ledger is fairly straightforward. It's a GET request into our blockchain adapter service, which calls into the ledger client, which again calls the chain code using the query operation and returns the data back to the calling service. So earlier on, I mentioned that Amazon Managed Blockchain helps abstract the complexity of running and growing a blockchain network. This page shows the proposal console for a test network. And in the center of the screen, you can see a proposal to invite a new member to the network. Current members of the network can vote on that proposal, and once it's been approved, the new member can use the blockchain console or the APIs to join the network and create their peer nodes. Once the peer nodes are created, the console also provides us with some metrics. This shows the detailed view of one peer node, and at the bottom left, you can see the number of transactions being committed on that node. We can also see the CPU and memory utilization metrics for that node, so we can understand the load on the system and correctly size our peer nodes so we're not overpaying for huge EC2s or limiting ourselves in terms of performance. That's all I had, so thank you very much, and I'll hand it back to Shruti.
For you guys. Available in ARIA, in Quad. Okay, now I don't need to use my loud voice anymore. Is in ARIA and Quad in level 1. And we have some of the websites that you can go to on Amazon.com, aws.amazon.com for more information. Now, if you guys answer some of our trivia questions, we have some nice echo dots for you. Coming first.
Raise your hand, please.
Raise your hand.
All right.
All right.
I see someone here.
Let's go here. Trust. Okay,
Right.
I was thinking C. All right. Okay, what are the 3 main components of a blockchain?
He
Sure.
looked enthusiastic on this. R. Good.
All right. Okay, you guys were all here. Good. What is Amazon Managed Blockchain?
Guy in the cap there.
There you go.
What's the answer? Hey, good job.
All right. This is going pretty well. How do I invite members to join my network? Anyone for D? No one for D, and someone for D. All right. There you go. There.
What's the answer?
A.
There, okay.
Make
All
sure,
right. You had to do a double take on that. Which one is not a consensus algorithm?
All right. All right, you. D.
D.
Nah. Okay,
Yes, D's
good
not.
job.
Okay, good. Okay, so we have about 5 minutes for Q&A. Nihar, can you come up on stage, please? Thank you.
Yeah, it's a good question. So the question is who actually sets up rules and who has the rights to set up channels. Essentially, the rules are being programmed into the chain code, right? Channel is just a mechanism, and it's literally just one way to actually, build a channel. But again, like as a member, you can say that I want to build this channel. I want to invite, let's say, member X to be part of the channel. You get to decide that. But in terms of like who sets the rules when the transactions are coming in, you would actually make that part of your chain code.
If we create a network, it is called as my AWS account. In that case, will I still be charged for like network because I'm leaving the network?
No. So the short answer is no.
No,
You won't be
you won't
charged
be.
for it. Any other
All
questions?
right?
Yes.
Okay. Yes.
Yes. Yeah,
Right.
it's the same order of service.
That's correct.
Sure, you have a question? Yeah, so let's say you leave the network and you want to come back in. Firstly, someone actually has to invite you, right? So the members of the network will invite you to join the network again. Once you accept, you can again be part of the same channel, and all the data will start rethinking, and you'll get everything that you want.
Sure.
So are the compute resources that are part of that, are my nodes basically part of my AWS account, or are they somewhere else? So are these instances that are created as a member, are they part of that member's AWS account or not?
Right. Your nodes will be in your AWS account. All of your assets will be in your account.
Do I get charged for those instances separately from the data being written by the network?
Yes, you get charged for the peer nodes, right? But if you're writing your applications and they're sitting in your account in another VPC, right, you'll be billed on that node separately. But for the peer nodes, you'll be billed by Amazon Managed Blockchain.
Sure. Yes, you should. Yeah.
In the Workday case, did you actually store the certificates in the blockchain?
Casey, you can come.
Is there a sign?
Sorry, can you repeat that?
Now, just so the certificates, are you actually storing the certificates in the managed blockchain? I guess I kind of got lost with does the managed blockchain come with the Ledger DB? And I'm just kind of confused where you're storing the actual data for the certificate.
So the credentials are not stored on a ledger, just the public keys of the entities that are involved. So like issuers, verifiers, and the holders of credentials.
You're actually storing the certificate, is that kind of in DynamoDB or somewhere else?
No, the credential is stored only on the user's mobile phone.
All right, let's go.
Can we return to this slide that lists all the other blockchain and managed blockchain related events so that I can keep hands on with that?
Yeah, we've got. Yeah, sorry.
No worries.
Yeah.
Can we get this presentation?
Yeah.
Yep, this will be available for you on SlideShare. Yeah, you can access it through the mobile app. Oh, sorry.
Yeah, go ahead.
So HyperLedger Fabric based on what if I have some members that want to run on their data on Azure or something? Can they be a part of my network until I start running on?
The short answer is we have that on the roadmap, but we can take that offline and we can have that discussion with you. And I'll be available after the session. Okay. Go ahead.
Why would you use QLDB? Because why would you need multiple device to do that? Because you're a single company, right? Why not do a centralized one?
In the future, we're going to have other partners that are also reading and writing from the ledger to interoperate with the same data.
Because you need to have selective amount of properties to do that, right?
Yes, maybe we can talk about that offline. Yeah.
So could you repeat your question a little louder? Yeah, in terms of like adding nodes, you could definitely have like, let's say 2 different sets of chain code that you would write to kind of get more throughput out of the system. So the answer is yes. All right, we're over time
Yep.
now, but I can take your questions after.
Thank Thank you, guys.
Thank
Really
you, everyone.
appreciate your time.